a little mistake, and a test. Alright, back with you again. It's 7:12 now. It's later in the afternoon, evening, whatever you want to call it. As I explained earlier in the video, what I came up with, I'm not really sure how many of you guys caught my mistake before I actually said something about it in the closing moments of the video. But on these bridge rectifiers that are use these type of layout, this indicates the positive N. And if you don't believe it, you can go down in here and look. There's a plus sign there, two squiggly lines in the middle, and a minus on this side. So now that makes this minus and this plus. So obviously I've either got, you can look at it, I don't know, several different ways, I guess. You could look at it that I have the, no, I guess you can't look at it several different ways. It's basically this way, and that's it. I'm going to have taken this, goes over to here, and this will go to here. So we'll have to make some changes, obviously. This is going to be moved somewhere else. I'm not sure exactly how I'm going to do it, but I do need to get that changed around. So I may just go ahead and remove this, because I actually would rather have plus over here and minus over here, but whatever, it's not a big deal. Alright, let me, I just want to go ahead and show you what I did. Let me go ahead and correct my mistake, and we'll bring you back and I'll go through it again. Alright, well, I think I have it, this power supply correctly mounted, yeah, I have it mounted. I'm going to kind of go over with, now this hasn't changed any, this is still plus, this is still minus, this is still the AC input. This wire here, obviously, is red, and it is plus. It runs from the plus terminal over here, and goes through the board there, and connects to the red terminal, or the plus terminal, and goes over here. Now where it comes out here is here, and it runs over to, again, the plus terminal of the capacitor. Remember our negatives over here, so, and it runs back to the plus terminal of the screw terminal output. Now our DC, or our negative is right here, and that's on this end. Runs over to the negative of the capacitor, and this wiring here didn't change at all. It just runs over to the output for the negative. And there it is. So that's really the only thing. Now here's where that other red wire on top connects to the positive, right here on this positive terminal. You can see it this way better a little bit, I think. So that just connects over there and sort of jumpers over to this plus terminal here. And our AC has not changed one bit. It's still exactly the same place it was. And everything is hunky-dory, I do believe. And we're going to give this a shot, see what it does. That's always fun. Tune for maximum smoke, I always say. So let me set up for that, and we'll bring you back. Alright, back with you once more. You can see I have the wires connected. I've got two greens for the AC input that runs around this wire here and into the variac output over there. And these red ones, red and black here, are the AC, or the DC, I'm sorry, output, and I've got those hooked up to my fluke meter over there. It's set on voltage, 200 volts, and I thought I'd give this a little shakedown. Nothing serious. I just want to kind of try it out a little bit. Now, there's no bleeder resistor on this, so you know, I don't think we really need one that bad, but I may put one on there just to see what we got. I've got a thing here. Let me put a, let's see, 10K, 100K. 100K, let's try 100K. Let's put this over here. And put this over here. put this in between. See what we come up with. I think Bob did the math on this. I can't remember what he said it was. 2 milliamps, something like that. So that should be alright. Alright, well, flip on the, got the voltage turned down, flip that on. And let's see if I can give you both things in view here. Easier said than done. There, you'll see if it smokes maybe. If it smokes, I'm leaving the room. Sorry. Alright, there we haven't got anything on there. We do have a little bit, but not much. Oh, there's 2 volts. 2.3 on the DC side. 4.4, 5.6 on the DC. Let's go up a little more. 7.4, 9.7 on the DC. Right, let's go up to 10 volts. Oops. 9.7 pretty close. 14.1 on the DC. Let's go up to 20. Alright, got 26.7 on the DC side. What I'm going to need is 42 volts on this, so I'm going to go up to 42 volts and see what that does. Not on the AC, on the DC. Alright, there's 42.6, 31.4 on that. That's pretty good. That would work right there for our voltage. So at least we know it will do that. Now I want the big test is I want to see how fast this bleeds off. So I'm going to turn the variac off. I'm going to watch the DC meter and see how fast it comes down. Alright, it's down to 40. Yeah, I say it's not fast. That resistor is not even warm. So we probably could come down a little bit on that. Not that it's a big deal, but I just want to make sure I'm getting the voltage bled off. So I think we pretty much proved that this is going to work. Now the only thing we need to do is prove that it'll go up to 200 volts. Now we're talking some serious smoke. Alright, so it's down to 33 now. Now I don't know if you notice this, but when the bleeder resistor is doing that, it slows down the further it goes. The process slows down, so that's okay. Again, that's not a big deal. We're going to be going up beyond that, so it's not a big deal. So let's go up again. Get our thing back. Let's shoot up here pretty good. And we're up to 50 volts DC. 60. 75, 81, 88, 9. Now you'll notice the ammeter there, if you kind of keep an eye on that, it's not even budged. So we're not really drawing much current. Okay, there's 100 volts even on the DC. Keep going up a little bit more. Now we've got, it's trying to do milliamp. No, that's 10, isn't it? I'm sorry. Okay, it's trying to do 10 milliamps current. We're at 136 volts now. Let's see, we're up to 152 volts, 153 on the DC side. Everything seems to be normal. Let me take my rather than use the finger method, I'm going to try the that resistor is at 82.5. Not very warm. But let's go on up. Everything seems to be in order. There's 170. Double check a resistor. 82.5. Not really much draw on that. So let's go to 187. 188. 90. And there is 200 volts. Okay, we ran above our thing, but I have to switch ranges. Now there's 200 volts even. So that's, what have I got on the 145.8? Not bad, not bad at all. I like that a lot. Let me check our resistor one more time. $82.5. Not bad. Kind of liking this. Now I'm wondering how fast this will bleed off at 200 volts. So anyway, what we proved here is the fact that this is going to work for... Now what I didn't do is put the scope probe on there. Let's do that. Let's see what kind of ripple we have on this thing. Let me get set up for that and I'll bring you back. Alright, what you can see there is the scope probe hooked up to, I believe that's number 1, I hope. Let's see, I never can remember how to do all this. Channel 1, channel 2, I think that's number 1 right there. I'm on AC. Now I'm on AC because put it on DC, you get a whole different ball game there. So now there's 85 volts. It's still going down. I'm going to let it go down a little bit more, and then we'll turn on the power and see what kind of... I've got it on times 10 on the probe, make it a little bit less see if we can... Alright, go ahead and turn this back on. I'm at 74. Should be able to get some kind of a... As soon as that starts to go back up. There we go. Alright, now we're on the Variac supply right now. I'm going to take this down. Now you can see what we got. That doesn't look too bad. If that's what I think I'm looking at. It should be though. So like I say, that's I'm at 52 volts basically on the AC side. Now on the DC I'm at 71. You can see that up above there a little bit if you look at it. Maybe I can get both of them things on there. There we go. Let me go up a little bit. See if there's any changes. Okay, there's 80 volts. It's pretty steady. Now, like I say, I don't even know if I've got this hooked up right, but I've got the negative of the probe onto the DC negative, and positive of the probe on the DC or positive. And like I said, I've got it on times 10. Let me put it off times 10 once, see if that makes any difference. If I can. Let me go down a little bit more. That's all the way down. Oh, wait a minute. There we go. What are we getting here? Not sure what that is. Could that be our... I guess that could be, couldn't it? Our ramp down there. Huh. That's interesting. Still at 80 volts. It's still not too bad, I don't think. So anywho, that's what that looks like on the scope. Dee. Alright, I think that's enough of that. I'll turn this back off. I think it's good enough to try that fissure out, I do believe. I'm going to let you watch the go down. I've got the variac off. And we'll turn the scope off so that's not distracting. So that's how fast it goes down on a 100K. May have to up, or I shouldn't say up, less I guess on, excuse me, on the bleeder resistor. I still haven't decided, made up my mind, because I don't know. Bob seems to think I'll get a spike in there if I don't have a bleeder resistor in there. But you know, there'll never be a time this is connected without a load on it that I can think of. And like I say, when you turn it off, the bleeder resistor kicks in. It goes, and the bleeder resistor I'm going to have in mind for the off position will be a lot quicker. It'll go down pretty quick. So you know, I can't see once you start out at 0 and you've got a load on it. I don't see the problem. He said something about taking the lead off or something like that. It might give a spike, but I don't know. I've done this many times before and never had a problem, so I don't know. Everybody says this and that and everything else, but you know. Let's see some video. That's what I say. Let's see some video from y'all. I think I'm going to... I just want to make sure it did work. I'm going to try this with something, a 9 volt something or other. That's what I want to do. See what kind of hum I get out of it. Where's my, what's the radio I've got that works now? Oh, the Ross. That's what it is. Alright, I'll bring you back for when I get this all hooked up, and we'll see what this sounds like with the on 9 volts. Alright, what we've got now is the Ross hooked up to the the power supply. Right now it's only got 0.6 volts on it. I don't have it turned on. So let's do that and see what we get on the Ross. Take her up to about 9 volts. Easy enough to do. Alright, there's 9 volts even. Definitely got some hum in there.
At 812-752-2835 or visit isuinsurancegroup.com.
People know you deserve intelligent answers to your questions, especially about.
We were right on. I can't show it to you right now, but 9.02 is what our DC meter is on.
They are receiving credits even to their customers. No offering loans to new customers.
Alejandro Cosentini set up Afluenta, which allows Argentinians to lend money straight to each other.
So I am getting some hum there.
In a country where interest
But
rates
not
are
real
now
bad.
at 60%, his business is thriving.
It's
Worry
usable.
about the future, because so far we haven't had a recession, but now
So,
there's signs that Argentina
I
could
think
enter
this
a
is going to work out
recession,
pretty good.
Very high inflation. So do you worry about the future?
Yes, of course. The government has, a huge challenge just to fix the economy.
Now what I'm
Just
going to do this time,
fix,
instead of turn the
the
radio
way
off,
we are doing business.
turn this off.
Do you have faith
See
that
how
this
long it
crisis
bleeds
can
down?
be
It takes to bleed
overcome
down.
soon?
To be honest,
Not very long. It's down to 2, 1, under 1 right now. So that didn't take long. So that's another method you can use if you don't want to use a bleeder resistor. Just you leave your load on there, and it'll bleed right off. Probably faster than it would with a bleeder resistor. So anywho, that's going to do that, and I think we're going to call this evening. I'm not going to be able to get the Fisher tested tonight. Saturday's another day, and apparently I don't have to get Kylie this evening and don't have to take her tomorrow in the morning. Well, I was going to have to take her for a test in the morning at the high school, but they are going to take care of it themselves, which, okay, that's fine with me. So don't have to do that. Like I said, that's that, and I'm happy of that. You know what I mean? I didn't want to have to. I'm still not happy with it. Like I said, there is a little bit of a hum to it, and I don't know if I can get that out of there with it without adding another capacitor or something like that. And I don't really know, but maybe the resistor would be helpful. And that I guess I could try that. See what I get from that. See if I'll hook up another couple clip leads across there, and put that bleeder resistor back in and see what happens. See if there's any difference. Alright, it's hooked up now. Bring you back down to high level. Turn this back on. Bring it back up. The radio should still be on.
When we were there, it seemed like there was a thriving black economy where people were, just trading in their own goods without exchanging money, and a lot of people working under the table, not paying taxes. There seemed to be a lot of corruption by New Zealand standards anyway.
And just briefly, Sharon, how does it feel, you listening now, hearing that Argentina is having not dissimilar difficulties again?
Oh, maybe it's a little less.
Accountants.
That's 98.3. Now you can see, I don't know, you can't see, but I'm running around 10 milliamps on the AC power supply. Aren't hardly anything there, so. I'll take this off and see what it does. Not really anything. We are right on 8.98, so right on 9 volts.
Throws it across the middle and overthrows ball here, incomplete. Gets it across the 25, across the 20, down to the 15-yard line, and another Seymour first down on the 11-yard pickup for quarterback Brendan Smith.
All right, again, I'm going to turn this off.
15. 5 Henderson goes left.
Goes down real fast with the bleeder and the load on it. So, all right, I'm happy with that. I'm not going to worry about the hum all that much right now. You expect a little bit of a hum coming right off the line like that, I would think. 2200 is a pretty big capacitor, but there are bigger ones. So, I don't know whether we need it or not. Let Bob watch this and see what he thinks, and he can tell me all his ideas. So, I'm going to try to get this up this evening if I can. You guys have a wonderful evening. Thanks for watching, and we will see you